Number 72. Number 72 talks about a solution that contains naphthalene dissolved in hexanes. So we have naphthalene, C10H8, and we also have then hexanes, which is C6H14. And it's a concentration of 12.35% by mass of naphthalene in hexanes. Calculate the vapor pressure at 25 degrees Celsius of hexanes. So we're looking for the pressure of hexanes at 25 degrees Celsius above the solution. The vapor pressure of pure hexanes is equal to 151 torr at 25 degrees Celsius. And so this will be our hexane solution. That's what we're trying to determine. And so in order to determine the pressure of a solution, we want to set that equal to the mole fraction of the solvent times the pressure of that solvent when it's pure, so the pure vapor pressure of that solvent. We already have the pure vapor pressure of that solvent, that's 151. We need to determine the mole fraction of the solvent in order to answer the question, which is asking us what is the pressure of the hexane solution. So we already have the pure vapor pressure of the solvent. We need to use this percentage by mass in order to determine what the mole fraction of the solvent actually is. So if we assume 100 grams, that means we would have 12.35 grams of the naphthalene. And then that would also mean that we would have then 87.65 grams of the hexanes. Right? There's only two things in solution, the naphthalene and the hexanes, and so both of them have to equal 100% or 100 grams. So if we have 12.35 grams or 12.35% by mass naphthalene, that means the rest of the mix has to be the hexane solvent, and so that would be equal to 87.65 grams of hexanes. We would then want to take each one of those values and divide by the representative molecular mass. So for our naphthalene, we would want to divide by 128, and that gives us 0.096 moles of the naphthalene. And then we would want to do the same thing for the hexanes. Take the 87.65 and divide it by 86. Gives 1.01 moles of the hexanes. So we have 0.096 moles of naphthalene, we have 1.01 moles of hexane, and so now we can use both of those to solve for our mole fraction. So our mole fraction of the solvent would equal the moles of the hexane over the total moles. So we would have the moles of the hexanes, which would be 1.01 moles over the total, 1.01 plus the 0.096 moles. And so that would be our mole fraction, which we could then use to solve for the pressure of the solution. So our pressure of the solution would equal our mole fraction times our pressure. When we do that, we get a value of 137.8 torr for the vapor pressure of that hexane's solution. Alternatively, you could have solved for the vapor pressure lowering and then subtracted that from the 151. So alternatively, instead of using this equation, you could have also solved for the vapor pressure lowering and gotten a delta P, and then solve for the pressure of the solution, which would equal the pressure of the solvent minus that delta P. That would be another way to go about that. You should get exactly the same answer, and that is number 72.